Welcome, welcome teachers and all the classmates to Group 1 presentation of the trigonometric system and sloping triangles. We have two contents, is the revision and the law of cosine. Before learning the law, let's do some revision. First is the system of quantity A2. Example, let ABC be a right triangle at A with attitude HA equal H and BC equal A, CA equal B, and AB equal C. Count BH equals second C and CH equals second B. Look at the figure 2.11. Fill the blanks in the following equation to get the coefficient in the right triangle. We have h squared equals b squared plus c squared. B squared equals a multiplied with second b. C squared equals a multiplied second c. H squared equals second b multiplied second c. A multiplied h equals b multiplied c. 1 on sec h squared equals 1 on b squared plus 1 on c squared. And the system of trigonometric radius, sin B equal cosine C equal B on A, sin C equal cos B equal C on A, tan B equal cos C equal B on C, cos B equal tan C equal C on B.
We go on to the law of cosines, including the law, consequence, and example. The first, the law of cosines. We have problem. A triangle ABC with two sides AB, AC, and angle A. Calculate BC. Look at the picture 2.12. We have BC square equal the length of BC square equal AC vector subtract AB vector square equal AC vector square plus AB vector square subtract 2 times AC vector AB vector. BC square equal AC vector square plus AB vector square minus 2 times the length of ABC AB multiplied cosine A. BC square equal AC square plus AB square minus 2 times AC AB multiplied cosine A. BC square equals square root of AC square plus AB square subtract 2 times AC AB multiplied cosine A. So we have the law of cosine with the triangle ABC and E, and BC is A, CA is B, AB is C. We have A square equal B square plus C square, subtract 2 times BC multiplied cosine A. B square equal A square plus C square minus 2 times AC multiplied cosine B. C square equal A square plus B square minus 2 times AB multiplied cosine C. The law of cosines is an equation that considers the two non-sides of a triangle and the cosine of one of its non-angles to find the one missing side. When a triangle ABC is a square, the law of cosines becomes Pythagorean theorem. Continue cosines consequence. From the formula of the law of cosines, We can be the calculation of the triangle angles as the following. Cosine A equal B squared plus C squared, subtract A squared divide 2 times BC. Cosine B equal A squared plus C squared minus B squared divide 2 times AC. Cosine C equal A squared plus C squared, subtract C squared divide 2 times AB. Also, applying the cosine function theorem can help us find the length of the median lines along the three sides of a triangle. In particular, in the ABC triangle, ABC, BC is A, ABC. If you place the median lines on the vertical sides A, B, C, and A, and B, and C, then we have MA squared equals 2 times B squared plus C squared minus A squared divided 4. MB squared equals 2 times A squared plus C squared subtract B squared divided 4. MC squared equals 2 times A squared plus B squared subtract C squared divided 4.
Now with the example. We have A, B, C, and D. We need you to choose the answer. Consider the below triangle ABC, where A is 10 cm, B is 7 cm, C is 5 cm. Find cosine x. Handbook, please.
I choose A.
Thank you for your answer. That is correct. Now is the solution. By using the cosine law, A squared equal B squared plus C squared minus 2 times BC multiply cosine x, or cosine x equal B squared plus C squared minus A squared on 2 times BC. Substituting the value of the sides of the triangle A, B, and C, we get cosine x equals 7 squared plus 5 squared minus 10 squared on multiplication of 2, 5, and 7. We have cosine x equals 49 plus 25 minus 100 divided for 70. The answer is minus 0.37. Example number 2. A triangle ABC has angle A 60 degrees. AB is 6 cm, BC is 8 cm. Find BC. Hoàng Quân, please.
I choose C.
Thank you for your answer. That is correct. The solution is apply the law of cosine in triangle ABC. We have BC squared equal AB squared plus BC squared minus 2 times AB multiply AC multiply cosine A. Change the number in, we get BC squared equals 6 squared plus 8 squared minus multiplication of 2, 6, 8, and cosine 60 degrees. BC squared equals 52. We get the answer 2 square root 13.
This is the end of our presentation. Thank you for your listening. And if your suggestions help to improve our presentation.
Good morning, our precious teachers and fellow buddies. Welcome to the presentation of Group 2. Showing on the screen is the contents that we'll be presenting. So let us begin with part 1, examples for the law of cosines with the first formula. Sorry, there's a few problems, so let us begin again. Good morning, our precious teachers and fellow buddies. Welcome to the presentation of Group 2. Showing on the screen is the contents that we'll be presenting. So let's begin with part 1, examples for the law of cosines with the first formula.
I can't see. The boy can see Phát ơi.
Người ta nói thấy mà.
Begin with the next slide. Okay. So this is the first example of part 1. Given is triangle ABC including side AC equal 10 centimeters, AB equal 10 centimeters, AC equals 7 centimeters, AB equals 10 centimeters. Angle A equals 65 degrees. Calculate the length of the triangle sine BC. And now this is our solution. We have A squared equals B squared plus C squared minus 2BC cosine A, which is equivalent to BC squared equals AC squared plus AB squared minus 2AC AB cosine A. BC squared equals 7 squared plus 10 squared minus the multiplications of 2, 7, 10 cosine 65 degrees, which is equivalent to BC equals 9.478 centimeters.
So let us move on to example 2. Triangle ABC is given, which has sides AB equals 5 centimeters and AC equals 6 centimeters, and angle A is equals 60 degrees. Find the length of BC and angle B. So with this problem, we have a small question for you guys. What is the length of side BC? Choose the correct answer. So please raise your hands. I will choose from you guys after listing all the options. A, BC equals the square root of 3.1 centimeters. B, BC equals 31 centimeters. C, BC equals the square root of 31 centimeters. And D, BC equals 31 meters. Ngân Hà, please.
I choose C.
So let us take a look at our solution to see if your answer is right or not. Finding side, BC square equals AC square plus AB square minus the multiplication of 2 AC AB in cosine A. And that equals to 6 square plus 5 square minus the multiplication of 2, 6, 5 in cosine 60 degrees. With that being said, we have BC equals the square root of 31 centimeters. So it seems like your answer is correct. Congratulations. Moving on to finding angle. AC squared equals BC squared plus ABA squares minus the multiplication of 2 BC, BA, and cosine B. And that is equivalent to 6 squared equals the square root of 31 squared plus 5 squared minus the multiplication of 2, the square root of 31, 5, and cosine B. And that leads to cosine B equals 2 times the square root of 31 over 31. And that leads to angle B equals 69 degrees.
And now we are going to part 2, the median line formulas examples. And this is the first example of part 2. Given is a triangle cone ABC, which has sides AB equal 10, AC equal 7, BC equal 12. Calculate the length of the median line corresponding to apex B of the given triangle. Here's our solution. Naming the side BC's midpoint M, meaning that we have BM as the median line of triangle ABC. We have BM squared equal BA squared plus BC squared over 2 minus AC squared over 4 equal 10 squared plus 12 squared over 2 minus 7 squared over 4. Thus it leads to BM equal 10.476.
Continuing with example 2, a triangle ABC containing sides AB equals 5, AC equals 6, and angle A equals 60 degrees. Find the length of the remaining side and segment AG, which G is the centroid of triangle ABC. Let's take a look at of our solution. Finding BC. Having BC squared equals AC squared plus AB squared minus the multiplication of 2 AC, AB, and cosine A. That equals to 6 squared plus 5 squared minus the multiplication of 2, 6, 5, and cosine 60. With that being said, we have BC equals the square root of 31. Going on with finding the median line AM. Calling AM as the midpoint of side BC, we have AM squared equals AB squared plus AC squared over 2 minus BC squared over 4. And that is equals to 5 squared plus 6 squared over 2 minus the square root of 31 squared over 4. And that leads to AB equals the square root of 91 over 2. The last part of this problem is finding AG. Having AG equals 2 over 3 times AM equals to 2 over 3 times the square root of 91 over 2. And that equals to the square root of 91 over 3.
And now this is the final example of part 2. Having two motorbikes B and C with the distance between them is 15 kilometers. Point A is 12 kilometers far from motorbike B. The angle made by BA and BC approximately equals 60 degrees. Knowing the speed of the motorbike B and C is about 60 kilometers per hour. Which motorbike will arrive at A first, and how many hours in advance will it arrive compared to the other motorbikes? And now this is our solution. We have AC squared equal BC squared plus BA squared minus 2BC BA cosine B equal 15 squared plus 12 squared minus the multiplications of 2, 12, 15 cosine 60 degrees, which is leads to AC equal 13.75 kilometers. Hours it takes motorbike B to arrive at A. TB equal 12 over 60 equal 0.2 hour. Hours it takes motorbike C to arrive at A. TC equal 13 multiply 75 over 60 equal 0.23 hour. Therefore, motorbike B will arrive at first. Hours in advance motorbike B will arrive compared to motorbike C. 0.23 minus 0.2 equal 0.03 hour.
Let's take a look at the credits of all the members that made contributions to this presentation.
Now this is the end of our presentation today. Thank you for your attention. Any feedback would be appreciated.
Thank you. Continue. Group 3 is about the law of sine.
So welcome to my presentation. Today we'll talk about the law of sine, or we can call it the sine theorem. So in this presentation, I have two contents that I want to talk about. The first content is talking about the law of sine, and the second is the example about it. So let's begin with the first content, the sine theorem. So find a triangle ABC with BC for A, AC for B, AB for C, and R is the radius of the circle. We have A over sin A equal B over sin B equal C over sin C equal 2 times R. So this is the formula of the sine theorem. Next, we will do some examples to reinforce this theorem. So let's begin with the first example. Triangle ABC has side length BC equal 45 centimeter. The measure of the angle B is 80 degrees. The measure of the angle C is 60 degrees. Calculate the measure of the angle A, length of AC and AB. So this is the picture of this example, and this is our solution. The sum of three angles and the triangles is 180 degrees. So we have the measure of the angle A equal 180 degrees minus 80 degrees and 60 degrees equal 40 degrees. And by the law of sine, we can find the length of AC equal BC times sin B on sin A equal 45 times sin 80 degrees divided by sin 40 degrees. And the result is about 69.9 centimeters. And we do the same at the ACH above. We can find the length of AB equal BC times sin C divided by sin A equal 45 times sin 60 degrees divided by sin 40 degrees. And the result is about 60.6 centimeters. And in conclusion, we will find the measure of the angle A is 40 degrees. The length of AC is about 69.9 centimeters. And the length of AB is about 60.6 centimeters. So this is the first example. Let's go to the second example. Triangle ABC has the measure of the angle A is 75 degrees. The measure of the angle B is 45 degrees. Calculate the ratio of AB on AC. So this is the picture of this example, and this is our solution. We have the measure of the angle C equal 180 degrees minus 75 degrees and 45 degrees equals 60 degrees. So by the law of sine, the ratio of AB over AC equals sin C on sin B equals sin 60 degrees divided by sin 45 degrees equals square root of 6 divided by 2. So overall, the ratio of AB over AC is square root of 6 divided by 2. So this is the end of my presentation. So thanks for listening, and hope you guys contribute some ideas to make my presentation better.
We are pleased to welcome today. The subject of our presentation is trigonometry. trigonometry, and calculation. Our group is class, so we're here today to give a lecture about the practical application of the law of sin.
So we have 3 exercises that are related to reality that will help you have a handle on the law of sins. Okay, so let's dive right into exercise 1. Ni's house has an attic 3 meters high above the floor. She needs to put a ladder at an angle of 70 degrees with the ground to ensure safety when she wants to go upstairs. Can you help her to calculate the length of the ladder to use?
Solution. We have an illustration. So from what we have got about the length of the upside BC is also the length of the ladder to find. Consider triangle ABC, right angled at A. We have sin alpha equal AB over BC, so we have BC equal AB over sin alpha equal 3 over 70 degrees. Approximate 3.19 meters. Conclusion: the length of ladder is 3.19 meters.
Okay, so then we will move to exercise 2. The submarine, which was on the surface of the sea, suddenly dived in the direction of the sea surface at an angle of 21 degrees. If the ship moves in the diving direction to 300 meters, how deep it will be? And remember that the result will be grounded to meters.
In solution, we have sin alpha equal BC over AC, so we have BC equal AC multiply sin alpha equal 3000 multiply sin 21 degrees approximate 107 meters. So a depth of 107 meters.
All right, see the last question. A boat that crosses the wide river is a boat of the gang that is always perpendicular to the river bank. But because the water is flowing, the boat's path is deflected by 300 meters and reaches an expected distance of 37 degrees. Knowing that the boat crosses the river in 80 seconds, what is the speed of the boat that is crosses the river?
In solution, AC equal BC over sin equal BAC equal 3000 over sin 37 degrees approximate 498 meters. Span of boat when crossing river. Span equal AC over time. Approximate 498 over 80 approximate 6 meters over second.
And that concludes our presentation for today. Thank you for your attention. Goodbye.
Thank you to all groups. In general, presentations are good. In the next lesson, I will give much to 4 groups. Goodbye and Merry Christmas. Goodbye, class.